All right, today we are going to talk through synthetic division. So we're going to take a polynomial and divide by x minus 3. One thing that's important about synthetic division, it only works if we're dividing by x minus c. No x squareds, no coefficients on the x's. Notice that it's minus c, so it'll be the opposite of what it looks like. So the first step is to write the coefficients of f of x in order of descending exponents, and write the value of c to the left. You'll notice that we make a sort of L shape here. Since we're dividing by x minus 3, that 3 goes on the outside, and then our coefficients go in order. 2, negative 5. Notice that we don't have an x squared term, so a 0x squared. Negative 4 plus 8. Then for synthetic division, we bring down the leading coefficient. Always bring it straight down. We multiply the leading coefficient by that x value out here. So 2 times 3 makes 6. And then we put the 6 right here, and we add straight down. And then we repeat. We multiply our sum by the c value, write that product, add, repeat, 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 repeat. So we added, we got 1. We take our 3 times our 1, we get 3. We add straight down, we get 3. We multiply. 3 times 3 is 9. We add, we get 5. We multiply. 5 times 3 is 15. We add, we get 23. The final sum is the remainder of f of x divided by x minus c, and the values are the coefficients of the quotient. So those values actually go right in order. So if this is our remainder, this is our constant, x squared, x cubed. So this answer is actually 2x cubed plus 1x squared plus 3x plus 5 plus our remainder of 23 over what we divided by, which was x minus 3. So let's divide 2x cubed plus x squared minus 8x plus 5 by x plus 3 using synthetic division. So we're going to put a negative 3 out front. Why negative 3? Because remember, we're dividing by x minus c. Well, in this case, to get the plus, it's x minus negative 3, so negative 3. Our coefficients, 2, 1, negative 8, and 5 in order. So the first step, we bring down that first number. Always just bring it straight down. Then we multiply. Negative 3 times 2 is negative 6. We add, we get negative 5. Multiply negative 3 times negative 5 is 15. We add, negative 8 plus 15 is 7. We multiply 7 times negative 3 is negative 21. We add 5 plus negative 21 is negative 16. I always like to make myself a little box there to remind myself that is the remainder. So now these are our coefficients in order. We have our constant, our x, and our x squared term. So our answer is 2x squared minus 5x plus 7 minus 16 over x plus 3. All right, now we're going to divide these using synthetic division. So for our first one, if we're dividing by x plus 3, we're going to put a negative 3 out front and put our coefficients in order. We have a 1, 4, negative 1, negative 1. Always just bring the first number down, multiply, I get negative 3. Add, I get 1, multiply, negative 3. Add, we get negative 4. Multiply, I get positive 12. Add, we get 11. Put a box around that last number. That is our remainder. We have our constant, x squared. So our answer is x squared plus x minus 4 plus 11 over x plus 3. Then let's divide this other one. We want to start by taking our 1, putting it out front, and putting our coefficients in order. 4, 1, negative 3, 7. Bring down the 4. Multiply, we get 1 times 4 is 4. Add, 1 plus 4 is 5. Multiply, 5 times 1 is 5. Add, negative 3 plus 5 is 2. Multiply, 2 times 1 is 2. Add, 7 plus 2 is 9. And there's our final answer. We put these in order. Constant, x squared. So we have 4x squared plus 5x plus 2 plus 9 over x minus 1 is our final answer to that division problem. So a few more to divide with synthetic division. If I'm dividing by x minus 4, I put a 4 in the front. Put my coefficients down. I have 1, negative 6, positive 5, 12. Bring down the 1. 4 times 1 is 4. Add, I get negative 2. Multiply, I get negative 8. Add, I get negative 3. Multiply, I get negative 12. Add, I get 0. So my final remainder is 0. So that means when I divide here, I get, let's see, constant x squared. So 1x squared minus 2x minus 3. No remainder part. All right, for this next one, we're going to put positive 4 out front again. We'll have a 1 minus 22, positive 40. All right, bring down our 1. Multiply, I get 4. Add, I get 3. Multiply, we have 12. Add, I have negative 10. Multiply, it's negative 40. Add, it's 0. Our remainder is 0. So that means it's divided in evenly. So remember x squared. So I have 1x squared plus 3x minus 10. Now brings us to the reason we actually care about dividing, the factor theorem. A polynomial f of x has a factor of x minus k if and only if f of k equals 0. So only if the value's 0 of that function. So let's show that these are factors. And when we say the value, sorry, we'll go back to this, we're also saying a remainder. So when I divide, the remainder is 0, then it is a factor. So let's show that x minus 2 and x plus 3 are factors of this and use that to factor completely. So I'm going to start, you get to pick which one you start with. Let's start with x minus 2. So I'm going to take f of x and I'm going to divide it by x minus 2. So we'll start by putting a 2 out front and putting our coefficients in order. 2, 7, negative 4, negative 27, negative 18. We bring down the 2. Multiply, I get 4. Add, I get 11. Multiply, I have 22. Add 18. Multiply 36. Add 9. Multiply 18. Add 0. That should be 0. If I tell you it's a factor, you definitely want to end up with a 0. So that means we have a constant x squared, x cubed. We are still working with 2x cubed plus 11x squared plus 18x plus 9. But if I take that and divide by my other factor, so notice I'm not going back to the original. I'm going to stay right here. I'm going to divide that by x plus 3. I could start over. In my case, I'm going to have to. I put a negative 3 out front. 2, 11, 18, 9. Ignore the remainder. We can just stack these, and I'll show you that in a little bit. We'll bring down the 2 and multiply, getting negative 6. Add to get 5. Multiply, negative 15. Add for 3. Multiply for negative 9. Add to get 0. Our final remainder is 0. Good. We have our constant x and x squared. We are left with 2x squared plus 5x plus 3. And now we can try to factor. So, let's see. The only way to break apart 2x squared is 2x and x. The only way to break apart 3 is 3 times 1. So to make a 5 in the middle, I know I need a plus 3 and a plus 1. So we want to factor f of x completely. So that means f of x. We take that first thing we divided by, x minus 2, times the second thing we divided by, x plus 3, times the factored version of the last part, 2x plus 3 times x plus 1. So we divided until we could factor. This also has a lot to do with synthetic substitution, which is actually the remainder theorem. If a polynomial f of x is divided by x minus k, then the remainder is f of k. So the remainder after synthetic division is the value of f of k. So let's evaluate using synthetic substitution. Basically, I'm going to take f of x and divide it by x minus 2. That's all I'm doing. So I put my 2 out front and bring in my coefficients. 5, 3, negative 1, 7. Bring down the 5, multiply to get 10, add it's 13, multiply it's 26, add it's 25, multiply for 50, add 57. Now I know that f of 2 is 57. Just the remainder, that's all I care about. Boom, done. So let's try this one. I'm going to put my 2 out front and my coefficients in. 5, negative 3, 4, negative 1, 10. Now evaluating 2 to the 4th power, then times 5 to the 8th power, 2 to the 3rd power, then times 3, and adding and subtracting was a bit of work. This way is much faster. Bring down the 5, multiply to get 10. Add, I get 7, multiply, 14. Add, it's 18. 2 times 18 is 36. Add, I get 35. 2 times 35 is 70. Add, I get 80. That's my final number. That's my remainder. So that means f of 2 is 80. If you don't believe me, we can grab a calculator and double check it. So I want 5 times 2 to the 4th power minus 3 times 2 to the 3rd power plus 4 times 2 squared minus 2 plus 10. Oops. 10. And look at that, I got 80. It works. So let's try one more here. We're going to put the negative 3 out front. On all our coefficients, I need a 0 for my x to the 4th power because it's missing. 1, negative 6, 2, 4. Bring down my negative 3, multiply to 9, add to 9, multiply to negative 27, add to negative 26. Now my numbers are getting very big. Negative 3 times negative 26. 78. Add, I get 72. Uh-oh, 72 times 3, 6, 21. Negative 216. So I have negative 214 times 3. Positive 642. Add, I get positive 646. So that means f of negative 3 equals 646. Much better than trying to figure out negative 3 to the 5th power and not dealing with all the rest of it. So one other thing we're going to talk about today is called the rational zero test. The rational zero test. Just kidding. We're not talking about the rational zero test today, but I did want to circle back to this problem. Now we can stack our division together without having to create new lines, and I just want to show you really quick how we do that. So I take my first one, all right, 2, 2, 7, negative 4, negative 27, negative 18, right? We already know what we're going to get. We're going to get 2, 11, 18, 9, 0, right? Copy these numbers down just so it looks just like it did before. And then we wanted to divide by negative 3. So I can take where I'm at right here and just create another division, ignore the constant part, or sorry, the remainder part, and do negative 3. Bring down the 2, multiply, add, multiply, add, multiply, add. Now I have a new remainder. Okay, I always take that last piece as a remainder. Constant, x, x squared. It's left with 2x squared plus 5x plus 3. If you don't want to have to write it out 2 separate times.